All right, so welcome back. In this video, we'll be looking at the addition and subtraction formula for this trigonometric function, that is for sine, cosine, and tan. So if we look at for sine, if you have sine alpha plus beta, what is sine alpha plus beta? It's just sine alpha cosine beta plus cosine alpha sine beta. So sine shares its operation with cosine. So sine will first of all act on alpha, then cosine will then act on beta, and continue in that manner, right? So for cosine has to finish all its operation first. So you see, if you have cosine of a plus b, you will see that it's just cosine of what? Cosine will have to finish first. So you have cosine alpha minus beta. This minus will change to positive. But if you have cosine alpha plus beta, it's minus here. And also you see that the cosine will have to finish acting on A, acting on alpha and acting on beta before it gives it to sine. Then for tan alpha plus beta, you see it maintains the sign in the numerator here. So if you have plus here is plus, then the denominator here is minus. So if you have minus here becomes plus, and then here it's plus. So take note of that. All right, so let's see how we can use these formulas to solve problems. So just like I said, what to watch out for, you have to watch out for this sign. This is plus, this is plus, this is also going to be plus. And this is minus, this is minus. So example 1 says we should find the exact value of sine 15. Now, sine 15, as you know, is not a what? It's not a famous angle. Now, since it's not a famous angle, we can use this idea to rewrite it as the sum or the difference of famous angle. So this we can use 45 and 50. So if we use 45 and 50, it means we're going to use the difference formula, because 45 and 50 will give us what? Will give us 15, which is what we want. Or we can also use 65 and what? And we can use 60 and 45. But let's just use 45. This we can write as sine of what? So this we can write as sine 45 degree minus 30 degree is still fine. And this we can expand it as sine 45 degree, then cosine of what? 30 degree, plus, minus, then now it's going to be cosine of what? 45 degree, and then sine of 30 degree. Because we have used what? We have used the fact that if you have sine alpha minus beta, it's nothing but sine alpha cosine beta minus cosine alpha sine beta. So what is sine 45? Is root 2 over 2. Cosine 30 is root 3 over 2 minus cosine 45 is still root 2 over 2, and sine 30, it's 1 over 2. Right. Yep. So this is what? This is just going to be root 6 over 4 minus root 2 over 4, which we can put together as root 6 minus root 2 over 4. Now, for the second one here, this is cosine. We know that cosine is even, so this is the same thing as cosine of 105. This is even property, right? Of cosine. Now, this is 105. We can split it as what? We can split 105 as 60 plus what? Plus 45. And now this is going to be cosine 60, cosine 45. Since this is cos, becomes minus sine 60 degree and sine what? 45. And what is cosine 60 is 1 over 2 times cosine 45 root 2 over 2 minus sine 60, which is root 3 over 2 and root 2 over 2. And this will give us root 2 over 4 minus root 6 over 4. Yep. So which we can write as root 2 minus root 6 over 4. Now, if you look at number 3, has to do with tan. But if you look at what we have, is tan 37 pi over 12. So the first thing is that this number is bigger than what? Is bigger than 2 pi. So first of all, we need to find the coterminal first. So this is going to be tan of what? 37 pi, because we know 37 divided by 12 is more than 2. So where we have to remove 2 pi. This is simply coterminal, yeah? And what is this? This is just going to be tan of what? 37 pi minus what? 24 pi over 12. Right? And what will this be? This is nothing but tan of 13 pi over 12. Now, this is 13 pi over 12. We can try to write it as what? As either sum, or we write it as what? As difference. But also, if you look at this, we can make life easy for ourselves. This is 13 over what? Over 12 is in which quadrant? You see, this is in quadrant 3. So we can use the reference. In quadrant 3, tan is positive, but we can write it as 13 pi over 12 minus pi. Now here we are looking for reference angle. Yeah. So this is just going to be tan of what? This is just going to be pi over 12. And then we can apply the sum here just to make life easy. So here we can write this as tan of one option is to write it as pi over 3 minus what? Pi over 4. This will do. So now we can use the formula. This is going to be pi tan pi over 3 minus tan pi over 4. Then you have 1 plus tan pi over 3 and tan what? Pi over 4. Okay. And this, what is tan 60 is root 3 minus tan 45 is 1 over 1 plus root 3 times 1. So it means that our final answer, tan 37, is it 37 pi over 12, It's simply root 3 minus 1 over 1 plus what? 1 plus root 3. All right, so let's do more examples. Now, look at example 2. Example 2 says, find the exact value of the expression, this. Now, if we look at these numbers here, this is 3 pi over 7, this is 2 pi. So we can see the angles are not, they are exactly the same, right? Yes. The angle here, let me do this here. The angle here, 3 pi over 7 is the same thing as 3 pi over 7. And 2 pi over 21 is the same thing as 2 pi over 21. So what does that mean? It means that we can write these as what? It means we can write this as, if you look at this, this is cosine, cosine, and this is sine, sine. So definitely this is going to be a cosine function. And since this is plus, it means we were going to have something like 3 pi over 7, and it's going to be minus 2 pi over what? 21. This is what it's going to be. So because if you expand this, you're going to get exactly what you have there if you use cosine of alpha minus beta. Now, what is this? This is the same thing as cosine. If you multiply this by 3 by 3, this is going to be also 9 pi minus what? So here is 9 pi minus 2 pi, everything over 21. So this just becomes cosine of what? 7 pi over 21, which is the same thing as cosine of pi over what? 3. And what is cosine of pi over 3? Which is the same thing as cosine of 30, right? Yeah, and cosine of 30 is what? Root 3 over 2. No, sorry, this will be cosine of 60, right? Not cosine of 30. So cosine of 60 is going to be what? 1 over 2. All right. For example 3, it says find the period and the what? And the amplitude. So for this case, you see now, here you have a combination of what? Of cosine, sine and cosine. This is sine, this is cosine. So it's going to be something, it's going to have to do with sine. So definitely this is going to be sine. Yeah, why is it? Because here we have sine, and here we also have sine. And the other term there has to do with cosine, yeah? So you see this is cosine, and this is cosine. So it means that we can write this as sine of what? Of, let's say, 5x. And since this is minus 3x. So this is what it is. So this is sine 5x. If you try to expand this, you will get back to this one. So sine 5x cosine 3x minus. And this is nothing but what? This is nothing but sine of 2x. So since this is sine of 2x, you compare with what? You compare with y is equals to a sine kx plus b, right? So you can see that now the period is nothing but 2 pi over k, right? Which is just going to be 2 pi over 2. Yes, which is just what? Pi. Then the amplitude which is absolute value of A, is nothing but absolute value of what? Of 1, which is 1. So the period is pi and the amplitude is 1. All right, so I think we can stop this here. We will take another video for the examples.